In this video, we're going to take a look at the operating system and its roles in computer science. So first things first, what's an operating system? So an OS, or operating system, is an example of system software. Operating systems allow us to have general purpose computers because it provides an interface between the applications we use and the hardware inside the box. It almost acts as a middleman between the users and the computer. Examples of this are Windows, Linux, iOS, Android, and many more. If we didn't have this middleman, we'd have to physically touch the components, plug in wires, different things, a little bit like this. So what is system software? System software is software that allows a computer to run properly. This is usually the bare bones software which we really need, unlike application software, which is for specific functions and entertainment, such as antiviruses, task manager, file explorer, and the operating system itself. Now, the operating system has a number of roles. So it provides us a HCI, which is human computer interface. It allows us as a human to talk to the machinery behind it all. It allows us to multitask, batch process, handle errors, running software, user accounts, allowing us to save things, copy things, paste things. It manages our processor, it manages the memory, it manages security and the input and outputs. It does so many different things that you don't even realize. Two things when we look at process management, that's multitasking and multiprocessing. So multitasking is where you split the CPU's time between all the processes, so each process gets a few cycles to complete a few instructions. It's then swapped out and it makes you believe that it's all happening at the same time when it's not. Whereas multiprocessing, we have more than one core to use and the work can be divided out and each of the processes can be all done at the same time. So there's 3 stages to actually processing an instruction. So we've got the process that's actually running, so it's going ahead doing its job, playing the game, whatever it is, and then you've got a process that is waiting, where essentially it's saying, can we start now? Can we start now? Are we there yet? 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 Until the operating system finally goes, yeah, actually you can start running now. And then a process can also be blocked. So this is where the operating system suspends it, and when the data that the process needs becomes available, it'll then be notified. Now this can't be done without the operating system sorting that out for us. So memory management. The operating system's memory manager allows us to allocate memory to a program, and then when we close that program, it has a thing called a garbage collector, which essentially gets that memory back, and then it swaps memory blocks in and out of virtual memory, so that's when we use the hard disk. And it'll prevent programs from accessing each other's memory, so programs can't spy on other programs. So let's think about security. If you've got some spyware on your computer, that's not going to be very good if you can keep reading all the data from all your other programs. It could reveal all of your sensitive information, or it could even control your web browser. So the memory manager stops programs from essentially fiddling with other processes. So when we allocate memory, what we do is the computer or the application, you'll double click it, and then the operating system will go to its memory manager, and it'll then say, right, how much memory does this program need? It will then look at what RAM's available, and it'll go, actually, there is enough RAM, so we're going to load the program. If not, it might say, actually, we need to put a little bit of it in virtual memory, or in older computers, it might just say, no, you can't run that. So you can see on my animation on the screen, the word processor needs a little bit more memory, so then it asks the memory manager, and then it then allocates a little bit more RAM to be used. But sometimes a process may use up more memory than it should. Now the operating system should stop people or stop processes accessing all the memory at once, because that will just hog it all up and you won't be able to do anything else. So the memory manager is also in charge of making sure one process doesn't take everything up. Now the file manager keeps track of where all your files are stored, how they're stored, follows how the operating system actually allocates different policies, such as user access. It uses available storage space efficiently for files, so you might have heard something called fragmentation and defragmentation on the newest version of Windows. You don't have to defragment anymore, because when you delete something, it will then make sure that your space essentially gets shuffled up, and then another piece of information will go at the end. It creates a record of all your file usage. It allocates files to users if they're free and if they've got permission. It deallocates files when they finish with it, and it manages things such as copy, paste, delete, and rename. So the file manager, it allocates a file by reading it from the hard disk, so that's your secondary storage, and then loads it into memory whilst updating a little record of who's actually using it at that point. That's why sometimes if you're on a network and you both open up a file, you and your friends there, and you might say that you need to open it read-only, the file manager's essentially making sure that you're not both editing the same thing at the same time. Now, before you allocate the file manager determines if the user is allowed to access the file, which is called access control. So if you've got a file that might be for a teacher and you're a student, you might not actually have the correct permissions to actually go about opening and viewing that file. And then the file manager deallocates the file by updating all the file tables and rewriting the file if it's been changed to the hard disk. Any process wanting to use that file will then be notified, and then they can use it. That's why sometimes as well, I know on a few different games, when you try and mod them or when you try and cheat, if you open up a text file from one of the game's files and change it, it might not actually update anything until you've saved it, closed it, and then reopened the game. And if you do in Python, if you do some file input and output and you have the file open, you won't see your updates until you close it and reopen it. So the file manager looks at the name of the file and it looks at the file extension. So I might have operating systems.pptx. Now, the file manager also manages which programs are default when opening a particular extension. So if I open a pptx, it should automatically figure out that I want to use PowerPoint. But if you've got, say, 3 different media viewers, then you might actually have to choose what the default application is. Now, another thing is device drivers. Okay, so when a user, say, prints, what the application will do is it'll make what a thing called a system call to the operating system. It will then use the device driver of the printer to translate this print request into something the printer can understand. It's like a little piece of software that translates and allows the computer, the operating system, to communicate with peripherals. And then it gets sent to the printer and then it prints. So the operating system needs to be able to actually manage these peripherals. So that's why when you plug in a new device, you hear like a little ding kind of sound, something like that. That is where the operating system recognises it's got a device, and it's usually a lot faster now, but on older computers, sometimes you have to actually wait for the device driver to get registered and understood before it can start being used. So the operating system needs to be able to register the device so it can be used, and it also needs to deal with the fact that they can be unplugged. Now, when you register or have a registration, it links the device with a device driver. So if you, for example, went and uninstalled all of your keyboard and mouse drivers, when you plug them back in, you'd have to load that back up again. Now, that was the operating system roles. Hopefully it was quite informative, and don't forget to like and subscribe, and I'll see you in the next one.